Most companies blame suppliers when quality issues appear: late deliveries, dimensional failures, process instability, customer complaints. The conversation usually sounds like this: the supplier didn't control their process. But after working in new product introduction and supplier quality for many years, I've seen something very consistent. Supplier quality issues rarely start at the supplier. They usually start much earlier, inside our own system. In today's video on Engineering Explained Simply, I am going to walk you through where supplier quality problems actually begin and why understanding this can completely change how you manage suppliers. Think about the typical product flow. Design gives RFQ, gives supplier selection, gives NPI, gives mass production, gives quality issue. When something goes wrong in production, we usually look at the last step, quality issue. But the real root cause, it often begins much earlier. Let's walk through the 4 stages where supplier quality issues are quietly created. Stage 1: Design phase. The first stage is design. This is where many supplier issues are unknowingly built into the product. I've seen drawings released with extremely tight tolerances, copied from older projects, without any discussion with manufacturing. No design for manufacturability review. No defined critical to quality characteristics. No capability targets communicated to suppliers. For example, specifying plus or minus 0.02 millimeters on a non-critical feature, without confirming whether the supplier's process can consistently achieve that. Later during production, capability fails, and we ask, why is the supplier struggling? But we rarely ask, was the requirement realistic in the first place? If design expectations are not aligned with manufacturing reality, supplier quality issues are already scheduled. Stage 2: Supplier selection. Okay, next comes supplier selection. And this is where commercial pressure often takes priority. Lowest cost, shortest lead time, quick availability. But how often do we deeply evaluate? Process capability history? Similar product experience? Equipment stability? Quality culture? If we select a supplier without validating their ability to meet our requirements, we are not reducing risk. We are transferring it into production. A rush sourcing decision today often becomes a corrective action request 6 months later. Stage 3: NPI phase. Now we enter the most critical phase, new product introduction. This is where supplier quality issues can either be eliminated or permanently embedded. Common gaps I've observed: no clear PPAP expectations, control plans reviewed only at surface level, no mandatory process capability study, sample parts approved visually, timeline pressure overriding validation depth. Sometimes we say, we'll stabilize the process after launch, but unstable processes do not magically improve in mass production. Mass production amplifies instability. NPI is the only structured opportunity to prevent recurring supplier issues. If this stage is weak, production will expose it. Stage 4: Production. Even if design and NPI were strong, production can still introduce issues. Engineering changes not formally communicated. Specification updates shared informally. No ongoing capability monitoring. Supplier performance not tracked consistently. Over time, small deviations accumulate. And when failures appear, we again say, the supplier has a quality problem. But in reality, the system allowed the drift. Big takeaway: supplier quality is not just a supplier issue. It's a system alignment issue. It starts with design decisions. Then, it's shaped by sourcing strategy. It's reinforced through disciplined new product introduction. And it's sustained by strong production controls. When these elements are aligned and robust, supplier quality stabilizes naturally. When they are weak or disconnected, supplier problems aren't surprising. They're inevitable. If this breakdown helped you see supplier quality from a different perspective, that's exactly the goal of this channel. On engineering explained simply, I focus on practical engineering realities, especially around NPI, supplier quality, and manufacturing systems. If this video created value for you, please like the video, share it with your engineering or quality team, and subscribe to support the channel. Your support helps me continue creating practical, experience-based content like this. In the next video, I will have more details about why ISO fails Part 2. I'll see you in the next one.